Okay, so let's talk about the informal rules then for significant zeros. Okay, we'll call them informal rules. Number one, leading zeros are not significant. Okay, leading zeros are not significant. Trailing zeros. Trailing a decimal and a non-zero digit are significant. Okay, kind of covers the same thing. Yep.
So if it was like 12.0, that would be like a significant figure?
Yes, it would be.
Yeah, because it's zero behind it.
Exactly. So, using that example and extending it a little bit further, 12 point, well, I'll tell you what, let's do this. Let's say 120.0. Let's do something different. Liters of hydrogen gas. Okay? Well, in this case, we have the last zero here, this zero right here, is significant because it trails a non-zero digit and a decimal place. Trailing meaning going to the right. Okay? Or using the formal rules, this zero is significant because it follows a non-zero digit and decimal place. Okay? Got that? That makes this zero significant because it's between two significant digits. Does that make sense? Two different rules make those two zeros significant. So this one is significant and then this digit is significant, is 0. Between two significant digits. And then non-zero digits are always significant. All right, let me repeat what this applies to, because these rules only apply to measurements or calculated numbers that have already been rounded properly. Okay? If somebody writes down a number from a measurement or a calculated number and they didn't handle the digits properly, you have to make an assumption about what digits are significant, but they might not actually be because the person didn't handle them right to start with. Now you wouldn't know that, so you have to assume. That makes sense. In this case, assumptions are valid. These assumptions are valid. Okay? Make sense? Yes.
Whenever because you said the point zero because it trails a significant number and a decimal, it's significant. But
Mm-hmm.
wouldn't that mean that like no matter what it is, because on every number is now always like a point zero? So wouldn't that mean every number is significant? You know what I mean?
No. Let's try this. I hope I've counted the digits right.
Isn't that a mole?
Okay? How many significant digits in this number? 4. All these other zeros are not significant. Okay? Or we treat them as if they're not. Okay? And the answer to the question somebody asked is yes. This happens to be Avogadro's number. And Avogadro's number defines the number of particles in 1 mole. Okay? Oh yeah. I have a former professor of mine. Yep.
So, two questions. Okay, that would be 6.022 times 10 to the 23rd, right?
Bingo.
Okay, and so if you were to put 0 after that, all of those zeros, including the one after the decimal point, would.
So if I put a 0.0 here, every zero in the number will be significant. Correct.
Yeah,
All right. Now back to the Avogadro's number. I had a professor, a former college professor of mine, who then had one of my students who claimed, I've never seen that number before. No, I know better than that because I always teach Avogadro's number. That just is something you just teach in high school chemistry. So he asked to see, do you have your notes from your high school class? Sure enough, she brought in her high school class notes, and there it was. You know, she just forgotten. Okay? So I've told you about Avogadro's number, okay?
How many zeros is that?
Oh, this is, the way we usually write this is 6.022 times 10 to the 23rd power. And it's particles of anything will equal 1 mole of that thing. Okay? How many particles in a dozen? Same thing. It's just a bigger number. Okay? There's 12 particles in a dozen. There's this many particles in a mole. Does that make sense? Yes? Kinda? Yep.
We did a lot of cool mole stuff last year. Like, we learned that if, like, there was a mole of moles, they'd be, like, their own planet and have their own gravitational field. Or, like, a mole of pencils is, like, the Earth. There's, like, so many.
Okay? If I remember correctly, if we had a mole of marshmallows on the surface of the planet Earth, they would be a pile 12 miles high all over the planet Earth. Yep. A lot of neat stuff you can do with that if you really want to go that route. Okay? But the mole is really important in chemistry because it makes conversions a lot easier. Now, conversions are going to be hard enough, but what we want to do is to make them as easy as we can make them and still have them be valid. Okay? Any questions? About significant zeros here, not about the mole so much right now. But now you've been told about the mole, so it's fair game. All right? Got it? All right. Oh, we got all kinds of tools we're going to use with the mole. We got mole maps and all this stuff. Okay. Let's stop this.